Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers Edexcel Paper 3. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find the link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on, and more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Right, 4.5 times 10 to the 5 is an ordinary number. Okay, so if I got 4.5 and I'm going to times it through by 10 to the power 5, that's equivalent of moving the decimal point 5 jumps to the right, isn't it? So it's going to go 1, 2, 3, 4, 5 jumps. So our decimal point is going to end up over here, which means I'd need to kind of fill in some extra zeros along the way in order that I can drop the decimal point there. So that gives me 450,000. The other way of thinking about it is 10 to the 5 is hundreds of thousands, so it kind of just translates your number into hundreds of thousands. Right, 0.007 in standard form. The way I do this, I just do it 7 times 10 and then I count the number of zeros I can see. So I can see 1, 2, 3 there, so it's going to be 10 to the minus 3. Okay, so 7 times 10 to the minus 3. Work out 4.2 times 10 to the 3 plus 5.3 times 10 to the 2. Give your answer in standard form. That's really easy with a calculator. Just have to type it in. So 4.2. You've got this exponent key down here with times 10 to the x written on it. So just press that, and then the only other thing you need to put in it is the power, which is 3. Okay, so 4.2 times 10 to the 3 plus 5.3. Type in the mantissa part. Press that button down there, times 10 to the x, and then tap in the power, which is 2. Okay, so what's that equal to? That equals to 4730, but remember they want it in standard form, don't they? Okay, so I'm going to have to rewrite that as the mantissa part as a number between 1 and 10. It's going to become 4.73. What's the power of 10? Well, the decimal point would start here. It's going to end up going 3 jumps to the left. So that is going to be times 10 to the 3 then, isn't it? So 4.73 times 10 to the 3. Hector can run 400 meters in 66 seconds. Use this information to show that he could run 5 kilometers in less than 14 minutes. So he can run 400 meters in 66 seconds. So what is his speed that he's running at then? We've been given this, which is distance traveled, and this, which is time taken, and I know a relationship between distance, speed and time. Do you? It's a handy little little triangle: distance, speed, time. Those letters are there alphabetically. That helps you work out what the equation is that links those 3 quantities. Now we want speed, which is down here, look, and that tells me that it's the other 2 divided by each other. So speed, or average speed, is distance traveled divided by time taken. So that would be 400 meters in 66 seconds. So calculator, what's 400 divided by 66? That comes out to be 6.06. Reoccurring 060606. I'm just going to round it off to 6.06. So that is 6.06 meters per second, isn't it? That's the speed they're traveling in. So if we know that that's the speed, and I'm going to be running at 5 kilometers, how long is it going to take me to run 5 kilometers at 6.06 meters per second? So then I want to find out time. So coming back to my triangle, if I covered up time, then it would be distance over speed, isn't it? So that's my next calculation I'm going to have to do. So time is equal to distance traveled over average speed. Okay, so now the distance is 5 kilometers. My speed though is in meters per second, so I'm going to convert that 5 kilometers to 5,000 meters and then divide it by 6.06. What's that going to give me? Well, I've got the last calculated value still as the answer. I'm going to use the full calculated value by using the answer key. So 5,000 divided by answer, that's given me 825. What unit is that going to be in? I had meters and I divided it by meters per second, so that is going to be seconds. 825 seconds. Now, what's that in minutes then? To convert minutes, to convert seconds into minutes, I'm going to divide by 60, aren't I? There's 60 seconds in a minute. So 825 divided by 60 would be what? 13.75 mins. Now that's a decimal, isn't it? So what I want to do, if it was any other sort of questions, maybe convert into minutes and seconds. But here I just need to show that it's less than 14 minutes, which I've kind of done already. So I'm just going to finish off with that then. So I can therefore say, Hector could run it in 13.75 mins. Right, and it says Hector tries to run 5 kilometers in less than 14 minutes. Give one reason why he might not be able to achieve this. Well, fairly obviously that 5 kilometers is a lot further than 400 meters, and you kind of run out of energy after a while, don't you? You know, you can't run at a sprinting speed for 5 kilometers. You've got to go at a slower pace. So what I would say here is that Hector may tire and slow down. A is a common factor of 72 and 120, and B is a common factor of 6 and 9. Work out the highest possible value of A over B. Okay, so this fraction is going to be its biggest when A is at its maximum value and B is at its minimum value, isn't it? Okay, you'll get a bigger number if you divide a fraction by a smaller denominator. So let's take B to start with then. I think that one's going to be easier. A common multiple of 6 and 9. If we want B to be minimum, we're actually asking for the lowest common multiple of 6 and 9. Okay, so let's think about the multiples of 6 and 9. The multiples of 6 are 6, 12, 18, and so on. And 9 is 9, 18, 27, and so on. So you can see we found our lowest common multiple already. 18 is there, 18 is there. So our LCM then of those two numbers is 18. So that's going to be my value of B. What about A then? We've got A is a common factor of 72 and 120. So let's list out the factors of 72 and 120. I tend to write them down in factor pairs. So 1 goes with 72. 2 goes with, well, half of 72 is 36. I think 3 must go into it then as well. So 3 and 24, is that? 3 and 24. 4 and what? 4 and, that's got to be 18, isn't it? 5, no, 6. Yeah, 6 goes into it. 6 and 12. 7, no, 8, yes. 8 goes with 9. And look, I've met myself coming down the other way, so that's as far as I'm going to get. So quite a lot of factor pairs of 72. What about 120? We're going to have so many. So I've got 1 and 120. 2 and 60. 3 goes with 40. 4, yes, goes with 30. 5 goes with 24. 6 goes with 20. Also got a lot of factors. 7, no. 8, yes. 8 goes with 15. 9, nope. 10, yes. 10 goes with 12. And then I've got 11 in between. That's not going to be a factor. So that's all of them. Gosh, lots of factors for both of those numbers. So we want the HCF then of those two numbers. So we want A to be as big as it can be. So it's going to be the highest common factor of those two. So looking through my list, 72, no, 36 is my next biggest. That isn't on my list. 24, yeah, that's on my list. So look, 24 there, 24 there. So the HCF of these two numbers is 24. Okay, so what's the highest possible value of A over B then? Is going to be, so that was my A value, wasn't it? 24, and B is 18. So my highest value is going to be 24 over 18. Okay. Which I could cancel down, but I'm not sure I need to. So it could simplify to 4/3. Also an acceptable answer. The diagram shows the results to the nearest percentage of a survey of 1,000 motorists. Driverless cars. Good idea, 20% think it is. Bad idea, 34% think it is. And not sure, 45% think it is. Interestingly, they don't add up to 100%, do they? Right, work out the largest possible number of motorists who thought driverless cars were a good idea. So actually, this is to the nearest percentage. It's a limits of accuracy question, isn't it? So if it was 20% to the nearest percentage, it means it's been rounded off to 20. Now, the next percentage up would be 21, and the next percentage down would be 19. So the ones that round to 20 are the ones that are halfway between those two. So the limits are going to be 19.5 and 20.5. They're the ones that round to 20 to the nearest percentage. So work out the largest possible number of motorists who thought driverless cars were a good idea. The largest possible is going to be the larger of those percentages then, isn't it? So I'm going to be using this upper limit then, 20.5, to calculate. Now obviously 20.5 you round up to the next value up, 21, but it still is the boundary and is still the one we calculate with. So largest possible is going to be 1,000 times by 20.5%, which is 1,000 as a multiplier. That's 0.205, isn't it? So that is 205. Now, strictly speaking, if it was 205 exactly, that would round up to 21% and not down to 20%. So I'm going to subtract 1 from that and write my answer as 204, because I know that definitely will round down to 20%. And the diagram shows a square-based pyramid and a sphere. The pyramid has a base length of 12.3 centimeters and a perpendicular height of 15.7 centimeters, and the sphere has a radius r. The pyramid and the sphere have the same volume. Work out the radius of the sphere. You must show your work in. Okay, we've been given the formula for pyramids and spheres, which is handy, so we have to remember them. Right, okay, so we know that these two shapes have the same volume, so these two things are equal in volume. Now we've got no measurements on the sphere, and we need to find out what r is, so we're going to deal with the pyramid first. Okay, so we're going to work out the volume of the pyramid, and then we're going to work backwards with the sphere formula to find the radius. Okay, so let's crack on with that then. So the volume of the pyramid is, what's that then? So the formula is down here. It's 1/3 times the area of the base times the perpendicular height. Okay, so 1/3 times area of the base times the height. Now, this particular pyramid is a square base pyramid, so the area of the base then is going to be this area here, whatever that is, and because it's a square, it's quite easy to find. That's just going to be 1/3 of the area of the base, then is going to be 12.3 times 12.3, isn't it? 12.3 squared, and then the height is 15.7. 15.7. Okay, so throwing that into the calculator, we should be able to find out the volume fairly easily. So 1/3, I'm just going to divide everything by 3 at the end, I think. So 12.3 squared times 15.7 divided by 3, and that comes out to be 791.75 equals 791.751. Okay, and then what we're going to do now, so now we need to work out the volume, well, the radius of the sphere, don't we? So we know that the volume of the sphere is equal to 4/3 pi r cubed. Okay, so subbing in what we know that then that is 791.751 there, and we want to get r by itself, don't we, really? So we're going to have to rearrange this to make r the subject. Okay, so I'm going to multiply through by 3 and divide through by 4 pi basically. So I'm going to divide by 4 pi and times by 3, aren't I? Okay, and that will cancel those all out on the left and the right, and then I'll get 791.751 over 4 pi times 3 then, aren't I? Okay, so the 3 comes up and the 4 pi goes down, and that is equal to r cubed. Okay, and then so to find r, we're going to have to cube root that then, aren't I? If I cube root both sides, then I'll get the cube root of all of that. Okay, r is the cube root of 791.751 times 3 divided by 4 pi, all cube rooted. Right, so let's type that in. So I'm going to use the root sign first. So cube root, shift, there it is. Shift cube root, and then I'm going to use the fraction key. 791, well, that's actually my answer, so I'm just going to press answer, times by 3, and on the bottom I'm going to have 4 pi. Okay, what's that then? That's 5.7389. I'm going to round it off to 3 significant figures. I'm going to say r is 5.74. R equals 5.74. Unit, centimeters. So 5.74 final answer. Aisha recorded the heights in centimeters of some girls. She used her results to work out the information in the table. Least height was 142, lower quartile was 154, interquartile range was 70, median was 162, range is 40. Aisha drew this box plot for the information in the table. The box plot is not fully correct. Write down 2 things that Aisha should do to make the box plot fully correct. Okay. Right, so let's just go through and check what she's done. Thing 1, she has drawn a scale. That's normally what you start with. Is that correct? It's going up in tens. There's no gaps. It's all looking good. She's marked the name of the scale, so that's good. That's the first thing you should do. Right, then what? She's written on the least height, which is 142. Is that correct? That's the least height there. That does look correct. Okay, that is at 142. The lower quartile, that should be at 154. That also seems correct. This is the lower quartile. It's the left-hand side of your box. Interquartile range is 17. So there isn't anything for interquartile range. The interquartile range is the width of the box. So that should tell you that the upper quartile, which is called Q3, that's going to be the lower quartile, 154 plus 17. So 154 plus 17, that's 164, 171, isn't it? So is the upper quartile at 171? No, it's not. It's at 172. Okay, so the first error is that she has got the upper quartile in the wrong place. So my first thing is upper quartile Q3 should be at 154 plus 17 equals 171 centimeters. Okay, right, so then that's that. Now, next thing, median at 162. You have gone cropper again there, haven't you, Aisha? So she's drawn it at 161. So that's the second thing. So median should be at 162 centimeters and not 161 centimeters as she's drawn it. Okay. Now, what's the last thing she did here? Range is 40 centimeters. Is that correct? The greatest height then should be at 142. The least height plus the range, that's 182. Now, actually, that is correct. Ran out of colors. Maybe use yellow again. So then the greatest height should be 182, which is correct. That one is all right. Okay, so we found all the errors. It's the median, and it was the upper quartile that was wrong. The diagram shows a cuboid and its diagonal, and the formula to work out the length of the diagonal in centimeters is length of diagonal equals the root of a squared plus b squared plus c squared. This is one of those interesting extensions of Pythagoras theorem. So when you move from 2 to 3 dimensions, all you got to do is add in your extra length then to work out the length of the diagonal. Quite cool. So what do we have to do here? Work out the length of the diagonal where A is 8, B is 3, and C is 2. We just need to put those numbers then into the calculation and work it out. So length is equal to the root of a squared, 8 squared, plus b squared, 3 squared, plus c squared, 2 squared. So, job for my calculator, root 8 squared plus 3 squared plus 2 squared. That gives me 8.77. Oh, two significant figures, 8.8. Okay, now part B then says work out the length of the diagonal in terms of A when B is 2A and C is 2A. Okay, so we've got to do the same thing algebraically now. So length is going to be equal to the root of A squared plus B is going to be 2A, so 2A squared, and C is going to be 2A squared, like that. So how many A squareds have we got then? I've got A squared plus 4a squared plus 4a squared, which gives me 9a squared, and the square root of 9a squared, well, the square root of 9 is 3, and the square root of a squared is a. So it gives me 3a. And obviously when you square root, you often get two results, positive and negative, but in this case there is only one solution that's valid, isn't it? It's 3a. Question 10. Eva writes 4 squared times 4 squared times 4 squared equals 4 to the power of 2 times 2 times 2, which is 4 to the 8. What is wrong with her method? Eva. I hope you haven't got your exam in a few weeks' time. Now obviously when you've got numbers with the same base and you multiply them together, you add the indices, you don't multiply them. So give the correct answer. Well, it should be 4 squared times 4 squared times 4 squared is equal to 4 to the power of 2 plus 2 plus 2, which is 4 to the power of 6. Describe fully the single transformation that maps triangle A onto triangle B. Now A and B are different sizes, so it's definitely going to be an enlargement of some sort. Now notice that A is the larger one and B is the smaller one, and we want to find the transformation that maps the larger one onto the smaller one. So it's going to be an enlargement with a fractional scale factor. So we need to know what that scale factor is, and we also want to know where the centre of enlargement is. Now to find the scale factor, we just need to find two sides that are the same and compare them. So let's have a look at that side compared to that one. This side is of length 3, this side is of length 1. So my triangle B is 1/3 of the original height, or the original length. So the scale factor is going to be 1/3. The next thing we need to know is the centre of enlargement. Now the easiest way to find that is to draw on some ray lines that pass through matching corners of your shape. So let's draw one between those 2 points. And let's draw one through those 2 points as well. You can see that these ray lines are converging on the origin. I could draw a third one in as well, but actually I've already seen what the answer is. So they're all converging on this point here. So that's the centre of enlargement. So to fully describe the transformation, I'm going to say that this is an enlargement with scale factor 1/3 and centre origin. Here is a sketch of the line L. The point P at -6, 0 and Q at 0, 3 are points on the line L, and you can see they've been marked on the diagram. The point R is such that PQR is a straight line. PQR is a straight line. So in other words, R is further along the line L. Okay. The point R is such that PQR is a straight line, and P to Q to QR, PQ to QR is in the ratio of 2 to 3. So for every 2 units we've got here, we've got 3 units up here then, haven't we? Okay. Find the coordinates of R. Okay. So I think all we need to do here really is to work out how far it is in this direction and how far it is in this direction. And then what we need to do is scale that up, don't we? And then we can use that to work out how far it is from here and how far it is to here, because they should be related by that ratio, shouldn't they? Okay, so how far is it in the direction of X, and how far is it in the direction of Y from P to Q? So if you have a look at the X coordinate of P, we're down here, look at -6. And then if you go to the origin, then you're going to be going 6 units to the right to get to the origin. So that's 6. And then to go from the origin 0, 0 up to Q, which is 0, 3, we are going 3 units up. Okay? Now, the ratio of this to this, we were told, was in the ratio of 2 to 3. So if we take those distances and we divide them by 2 and we times them by 3, we should get the corresponding distances for the next bit from Q up to R. So if I take 6 and I divide it by 2, I'm going to get 3. And if I times it by 3, I'm going to get 9. Okay, so if you think about it in the other way, if I've got the ratio 2 to 3, if I've got 6, that is 3 times bigger than that one. So times that by 3, I'm going to get 9. Okay, they're going to be in the same ratio. So that must be 9 there. Okay, now if I've got 3 on this side and I want to know what it is on that side, that's a little bit trickier. Well, basically it's half that one though, isn't it? It's going to be 4.5 by just taking that and dividing it by 2, I suppose. We can do that, divide by 2. So and then I'm going to have, for 3 there, I'm going to have 4.5 here, which is kind of 3 halves of the previous one, isn't it? Okay, so how does that help us? Can we use that to find the coordinates then? I want to find the coordinates of R. So if I'm at Q and I'm at the coordinates 0, 3, and I go 9 units to the right, then my R coordinate then is going to be 0 plus 9. It's going to be at 9 there. Okay. Then for the Y coordinate, if I'm already at 3 here in the direction of Y and I go up another 4.5, that's going to take me 4.5 units above 3. That's going to take me up to 7.5. So my Y coordinate for R is going to be 7.5. So the coordinates of R are 9, 7.5. Right, and then part B says find the equation of the line that is perpendicular to L and passes through Q. Perpendicular to L and passes through Q. So the line that is perpendicular to L passing through Q is going to look something like this. Okay, now, and that's at a right angle, isn't it? Now, to find the equation of this line, every equation of a straight line is of the form y equals mx plus c, isn't it? Now, I already know the y-intercept of this line because it's, well, basically it's here, isn't it? Okay, I know where it passes through the y-axis. It passes through it y is equal to 3. So I know c already. C is equal to 3. Now, do I know the gradient? No, but I could find it, couldn't I? Because I could use the information I know about L to find the gradient of L. And then I could use that to find the gradient of the perpendicular line, couldn't I? So let's find the gradient of L. Gradient of L, which I'm going to call M1, that is going to be change in y divided by change in x. Okay, now I'm just going to take the first triangle because the numbers are easier. So if you remember, it was 3 units up and 6 units along from P to Q. So the change in y, 3, divided by the change in x, 6, gives me a gradient of a half. Okay, so then the gradient of my new line, so the gradient of the perpendicular line, which I'm going to call M2. Now the gradient of a perpendicular line is the negative reciprocal of the other line. So if I know M1 is a half, then I can flip that over. So half becomes 2 over 1, or just 2, and then I change the sign so it becomes minus 2. So my perpendicular line has a gradient of -2. I already knew the y-intercept was 3, so now I know everything I need to know for this line. If the gradient is 2 and the intercept is 3, then I can plug my gradient in there and I can plug my intercept in there, and then I've got the equation of the line. So therefore, equation of line is y equals m minus 2x plus c, 3. Y equals minus 2x plus 3. Sophia is competing in the long jump competition. Her first jump is 5.25 meters. Her best jump is 8% more than this. However, her best jump is 10% lower than the winning jump. Work out the length of the winning jump. So let's just try and visualize that. I've got a 5.25 was her first jump. Her best jump was 8% above that. But as good as that one was, it was 10% less than the winning jump. So that was her best, and this was the winner. Okay, so let's work out her best jump first off. So best is going to be, well, it's a percentage increase, isn't it? So using our triangle final original multiplier, our final is what we're trying to get. Our original is 5.25 and our multiplier is, well, it's 100% plus 8%, which is 108%, which is 1.08 as a multiplier. So our final is equal to our original times our multiplier. In this case, the original was 5.25 times a multiplier of 1.08, and that gives me 5.25 times 1.08 gives me 5.67. So 5.67 is a very best jump. Okay, but the winning jump, well, this 5.67 is 10% lower than the original amount. So the winning amount is, well, the winning amount subtract 10% is 5.67. So I actually want to do a reverse percentage here. So for the winning one, our final is 5.67. It's her best one. Our original is what we're trying to find, and the multiplier is going to be 100% less 10%, which is 90%, which is 0.90 as a multiplier. So using again the triangle final original multiplier, this time we are looking for the original, and we're going to use final divided by multiplier to find it. So that is 5.67 divided by 0.90, which is 6.3 meters, so 6 meters and 30 centimeters. That's a long jump. She's nowhere near it. The number of goals scored by 20 players in the season is shown. So 0 to 4 goals 6, 5 to 9 goals 11, 10 to 14 goals 3, giving a total of 20. Okay, work out an estimate of the mean number of goals per player. Give your answer as a decimal. Okay, now this is group data. So in order to work out a mean, well, I can't work out a mean. I can estimate the mean though by estimating the number of goals between 0 and 4, coming up with a representative value. Okay, now what is the mid value of 0 to 4? Now, a number of goals is actually what we call discrete data, so it's only whole numbers. So, you know, if you hold up your hand and count 0, 1, 2, 3, 4, then you can see your middle finger is actually the 2, isn't it, of that. So the midpoint of 0 to 4 with discrete data is going to be 2. Oops. It's going to be 2. Okay, similarly with 5 to 9, if you hold up your hand and count 5, 6, 7, 8, 9, then your middle finger is going to be the 5, 6, 7, isn't it? It's going to be the 7. And then 10 to 14, 10, 11, 12, 13, 14. It's going to be 12 as the midpoint. Okay. So, yep, they're the mid values, and then we can just multiply those together. So f, the frequency, times the mid value, x, gives us 6 times 2 is 12, 11 times 7 is 77, 3 times 12 is 36. So adding all those up, sigma fx, the sum of the frequencies times the values, 12, 77 and 36, what's that? 77 and 36 is 100, 113, plus 12 is 125 then, isn't it? So sigma f, sum of the frequencies, I've already been given here, is 20. So then the estimated mean is going to be sigma fx divided by sigma f. Okay, that's the official formula for it if you didn't know. 125 over 20. What's that then? 125 divided by 20. Comes to 6.25, 6¼ goals. We're told that the density of steel is between 7,750 kilograms per cubic meter and 8,050 kilograms per cubic meter. We're given that 1,000 kilograms per cubic meter is equal to 1 gram per centimeters cubed. And we're told that a solid metal object has a volume of 1,430 cubic centimeters, and we know the mass of the object is 9.6 kilograms. And the question is it possible that it's made of steel? Right, so we know that density is equal to mass divided by volume. So we've been given the volume of this metal object and we've been given its mass, so we should be able to find its density. So density equals mass over volume. So in this case the mass is 9.6 kilograms. Okay, that's not very helpful because this is in centimeters cubed and this is in kilograms. Let's convert this into grams first. So it's 9,600 grams. Then we can make a density in grams per cubic centimeters and then convert it. So 9,600 grams divided by the volume, which is 1,430 cubic centimeters. Now, according to my calculator, that is 6.71. 6.71. That's going to be in grams per centimeter cubed. So then we can convert that into kilograms per cubic meter by timesing through by 1,000. So that is going to be 6,710 kilograms per cubic meter. Now, does that lie in our range? No, it's too low, isn't it? So it's too low to be steel. So it is definitely not steel. Too low to be steel. Make F the subject of the formula. Now you need to take care with this one because actually F appears in two places. It's down here and up here. So it's one of the hardest sorts of rearrangements that you need to do. And it's going to involve some extra steps. Right, so the first thing I'm going to do is I'm going to cross multiply the denominator. So I'm going to multiply through by this bit down here. So I'm going to multiply both sides by F minus 4. So if I times F minus 4 on both sides, F minus 4 times that, it's going to cancel with that one. And it's going to leave me with D lots of F minus 4 equals 3 lots of 1 minus F. Okay? Now multiplying out the brackets, that's going to give me df minus 4d is equal to 3 minus 3f. Okay? So I've got f's on both sides. We're going to have to get all the f's on one side. So I'm going to add 3f to this side and to this side. Okay, so it gets rid of it there. And that's going to give me df plus 3f minus 4d is equal to 3. And then I'm going to do the opposite of minus 4d. I'm going to add 4d to both sides. Okay, so then that cancels with that. And it leaves me with df plus 3f equals 3 plus 4d. Okay, now notice I've got an f in both of these expressions. I've got an f there and an f there. That means I can factorize out the f. And that's going to give me d plus 3 in the bracket equals 3 plus 4d. And then finally I can divide both sides by d plus 3. And so then that will cancel with that. And it'll leave me with f on the left hand side, and I'm going to get 3 plus 4d over d plus 3. So the trick of these ones, when you've got f appearing in two different places, you want to try and collect them all on one side and either, collect like terms or factorize out the f out of the various terms if you've got other things multiplied by it. Okay, job done. The ratio of number of boys to girls at a party is 3 to 4. 6 boys leave the party. The ratio of the number of boys to girls at the party is now 5 to 8. Work out the number of girls at the party. Now, the ratio of boys to girls we're given as 3 to 4 to start with. But notice in the second part we're given the ratio of girls, well, the number of parts of girls is 8, which is twice as much as we've got here. So in order to compare the two more easily, I can scale up this ratio by a factor of 2 and rewrite it as 6 parts to 8 parts. Okay, so we're told that 6 boys leave the party. And then we've got a new ratio of boys to girls of 5 to 8. Now, notice that this 8 here and this 8 here are the same, so the number of shares for girls is the same, and the boys has gone from 6 to 5, so it's reduced by 1. So overall, we've reduced the number of shares of boys by 1 when 6 boys left. So I conclude from that that 1 share is equivalent to 6 students. So if we then take our ratio of boys to girls and times it up by a factor of 6, we'll find the number of students of each type overall. So 6 times 5, there should be 30 boys, and 8 times 6 should be 48 girls. So we need to work out the number of girls at the party, which is this number here, 48. Girls at the party, 48. Okay, on to circle theorems. A, B and C are points on a circle. CD is a tangent to the circle. And we need to write down the size of angle X and give a reason for our answer. Okay, so here's angle X. It's the angle between the tangent and the chord AC. Now, because I know my circle theorems, I've easily spotted that because this is a tangent and this is a chord drawn at the point of contact, and this is an angle subtended off that chord in the alternate segment, then I know that that angle there is the same as my angle X. That's the alternate segment theorem in action. So I can just say that X is 65. So X is 65 degrees, and the reason is the alternate segment theorem. That's just enough. Just writing that down as the reason is good enough. Lucy makes 5-digit number cards using all of these cards. 3, 4, 6, 7 and 9. So how many different numbers greater than 50,000 can she make? Okay, so let's consider her choices. If she's going to make numbers bigger than 50,000, then there's a restriction on her first selection of her first digit card. She can only pick one of these 3 to start off with then. So she's got 3 choices for her first selection. For her second selection, doesn't matter which one of those 6, 7 or 9 she picks, she'll have 4 other choices for her next digit number. Then she'll have 3 choices for her next digit, and 2 and then 1. So the total number of selections that she's got is going to be 3 times 4 times 3 times 2 times 1. which is 72 choices. So we get to finish off the paper with a 5-mark algebraic fractions question. What joy. Okay, so we've got a complex looking pair of fractions multiplied together, and we need to show that it simplifies to a slightly nicer looking algebraic fraction. Okay, so we know about how to combine two fractions together normally. If I have a much simpler fraction like a over b times c over d, we would just say that, wouldn't we? We would say AC is equal to BD. We just multiply the top with top, bottom with bottom, and then we'd see if we can cancel anything out. That's exactly what we're going to do here. We're going to put all of this over into one fraction and then see if we can cancel anything. Okay, so let's start with 2w plus 4 over w squared minus 25 times w plus 5 over w squared plus 3w plus 2, and that's going to equal to something all over 1 divisor. So 2w plus 4 times w plus 5 over w squared minus 25 times w squared plus 3w plus 2. Now, can we cancel anything here? Just having a look at what's on the bottom of this, I've got we've got two quadratics on the bottom. Now, the one on the left, this one here, is actually the difference of two squares, w squared minus 25. If you remember your identities, then a plus b times a minus b is equal to a squared minus b squared, which is what we've got going on here. So that part there becomes w plus 5 w minus 5. The other side of it, this bit here, is a quadratic. Can we factorize it? So does it factorize into two brackets? Well, if it did, it'd have a w and a w there. I have two numbers that multiply together to give me 2 and add to 3. So w plus 2, w plus 1. And that is over w plus 5 that we can't do anything with, and 2w plus 4, which we can do something with. So this part here, look. So that bit was that bit there. That bit was that bit there. That bit stayed the same, and the 2w plus 4 can become, or we can factorize 2 out of that, and it becomes 2w plus 2. Okay, so that's the blue bit. So we've kind of gone through and we've done little bits to each of those expressions. So now what? Can we cancel anything top and bottom? So I've got a w plus 2 there, which I can cancel with that w plus 2. And I've got a w plus 5 there that cancels with that w plus 5. So they all disappear. So that leaves me with 2 over w minus 5 w plus 1. Okay? So what we've done so far is we've multiplied these two things together. Now we still need to multiply that expression with this other bit on the end here, that bit. So that's the bit we're going to do next. So 2 over w minus 5 w plus 1 times 3w squared minus 16w plus 5. What's that equal to then? Well, that is 2 lots of 3w squared minus 16w plus 5 all over w minus 5
w plus 1. Now, it would be very handy if that top quadratic 3w squared minus 16w plus 5 would factorize, and I can then cancel it out with another one of my factors on the bottom. So does that break up into two brackets? Well, if it does, it's going to have a 3w here and a w there, and the numbers are going to have to multiply to 5 and add to minus 16. So if we put a minus 5 in there and a minus 1 in there, then that kind of works, doesn't it? So 3w times the minus 5 would give me minus 15w, and the minus 1 times the w would give me minus w, give me minus 16w altogether. So that does work. Right, so then can we cancel anything now? Again, I've got a w minus 5 there and a w minus 5 there, so they can cancel each other out. And I'm left with, what's left? We've got a 2, we've got a 3w minus 1 over w plus 1. Now, is that of the right form? Let's have a look back. Show that it simplifies to aw plus b, cw plus d. We're almost there. I think what it wants then, to make it into that form, I just need to multiply out the top part. Seems a bit counterintuitive, but let's do it. 6w minus 2 divided by w plus 1. Now that seems to be in the form required. I've been given two functions of x, f of x equals x squared plus 1 and g of x equals x minus 5. I need to show that f of g of x is that expression there. Now f of g of x means take g of x and put it inside f of x, which basically means wherever I see x in my f of x expression, like here, I need to replace it with that expression. So I'm going to take my x squared plus 1 and insert x minus 5 in where I see the x. Okay, and then I need to multiply that out. X minus 5 all squared. Now last time I did this, I did it the long way, but this time I'm going to use the identity. If I've got a minus b all squared, then that is a squared minus 2ab plus b squared. This is a very useful identity to remember. It makes it multiplying out these things a lot quicker and easier. So that gives me x squared minus, so 2 times a times b in this case would be minus 10x plus 25 plus 1. So then just joining those last two things together gives me that. So done. Now part B says solve fg of x equals gf of x. Okay, so we've already worked out what fg of x is. What's gf of x? So gf of x is equal to, well, we take our function of f of x and we feed it into our g of x. So this time round, our x is here and we're going to replace it with this expression. So that is going to sit where that is in there. So I'm going to get x squared plus 1, my x, take away 5, which is x squared minus 4, isn't it? Okay, now I need to solve fg of x equals gf of x. Now we just showed that fg of x is x squared minus 10x plus 26. So x squared minus 10x plus 26, And we now know that's the same thing as x squared minus 4. Okay, so our x squareds cancel, and we are left with minus 10x plus 26 equals minus 4. Okay, so I'm going to move the minus 10x to this side, and I'm going to move the minus 4 to this side. So that gives me 26 plus 4 is 30 equals 10x. So x equals 3. The diagram shows a logo. We're told that ABE, this one, is congruent to DCE. So these two triangles are the same area. Okay, and we're told that BCE is a sector of a circle. Okay, so what do we need to do? Show that the area of the logo is 510 centimeters squared to two significant figures. Okay, so we're going to have to work out the area of one of these triangles. We can use the fact that it's congruent to double it up and then find the other one. Plus we need to work out the area of the sector. Right, do we have all the information we need? Not really. To work out the sector, I'm going to have to work out the radius of that circle. I can easily work out the area of the square. That's going to be of the triangle. That's going to be no problem. I can just use trigonometry to do that. But I'm going to have to then use trigonometry again to find r, so I can work out the radius, and so I can then work out that sector. That's going to be the trickier bit. Because it's a non-right angle triangle, so I think we're going to be using cosine rule, aren't we? So it's going to be quite long. For 5 marks, that's a lot of work. Okay, let's get busy with it then. So the area of a triangle, area of the triangle is going to be half AB sine C. That's our formula for an area of a triangle using trigonometry, which is our two sides and our included angle. So it's going to be a half A, which is 26, times B, which is 15, plus our included angle sine 38. What's that then? So 0.5 times 26 times 15 times the sine of 38. I make that 128.053. Okay, I'm going to give my final answer to... Oh, actually, I don't need to... It's only two significant figures. Let's just round it off then. I'll leave it like that. Okay, so that's the area of one of my triangles. So then my sector, I'm going to need to know r first. So I need to know that radius. Now I was saying earlier about sine rule and cosine rule. Sine rule is about opposites, and the cosine rule is either two sides and an included angle, which has got here, look, two sides and an included angle, or it's having three sides and wanting to find an angle. So I know that this is going to be the cosine rule this time. So can you remember the cosine rule formula? The cosine rule formula says a squared equals b squared plus c squared minus 2bc cos a. Now that's the way around you use it to find a length, which is what we're trying to do here, isn't it? Okay, so in terms of this diagram, our r squared, our a squared, is going to be our two lengths squared, so my 26 and my 15. 26 squared plus 15 squared minus two lots of 26 and 15 cos the angle, which was 38. So calculator time. 26 squared is 676. 15 squared, you can also just type this in all in one go if you want as well. Minus 2 times 26 times 15, 780, cos 38. What's that then? 676 plus 225 minus 780 lots of the cosine of 38. I make that 286.3. Remember, that's r squared, so r is going to be the root of that. So square root in my answer. I make that 16.92. Always good just to check for sensibleness. Does that look right in that diagram? 16.92, a bit under 17. That looks good. Okay, so now we found r, we can then use it to find the area of that sector then. So our area of our sector is going to be the fraction of the circle that we've got. So the angle is 108, so it's going to be 108/360ths of the area of the circle, which is pi times r squared, which in this case is going to be 108/360 times 16.92. I'm running off the side of the page. 16 times 92 squared. So let's type that into the calculator. 108 divided by 360 times by pi times by our last calculated answer squared. So I make that 269.88. Where do I have to write the answer? Oh, I just need to show it. I'm running out of space though, aren't I? Okay, I can still squeeze it in, I think. So then total area is going to be 2 times the area of the triangle plus the area of the sector, which is 2 times 128.05 plus 26988, which is equal to, I'm going off the bottom of the page here, which is very naughty, shouldn't do that in the exam. So plus 2 lots of 128.05, 525.98. What am I aiming for? Show that the area of the logo is 510 centimeters squared to 2 significant figures. Well, I get 530 to 2 significant figures. Okay, I'm not quite getting the answer that I was meant to here. I make that 520 something, where the answer here says 510. So I'm just going to go through and double check all my work. And I've just realized that I've made a mistake here when I read the calculator value. I did put the right thing in the calculator, but for some reason I misread the output, and it should be 120.05 there. Now luckily that doesn't change any of my other answers all the way down to this point here. That one there should be 120.05. So let's just type that in again. 2 times 120.05 plus 269.88. Oh, that's much better. That gives me 509.98, which definitely does round off to 510 to 2 significant figures. Okay, so what's the units? Centimeters squared, isn't it? So we have got there. I just made a bit of a silly mistake here. I misread my calculator value. So that is actually a good thing about these sorts of questions, where you have to show that that calculation is equal to a particular number, because you can error check whilst you're in the exam, like I just did then. So happy I've got it right now. Let's move on.
In a class there are n boys, a total of 25 students. 2 of the students are chosen at random. The probability that both students are boys is 7/20. Work out the value of n. Okay. Right, so a quick tree diagram to think about this. Let's say you pick a student, and it's either a boy or it's not a boy. Okay, and then if you pick a boy, you can have another choice, and it's a boy or it's not a boy, or it's a boy or it's not a boy if you chose it the other way around. Now, there are n boys and a total of 25 students, so the probability that you picked a boy first time is going to be n/25. Okay, and then so the probability that you picked a boy the second time, well, you got one less boy to pick from, and you've got one less student to pick from, so it's n-1/24. Okay, so if you wanted to pick the probability of boy, it's going to be this route through the tree diagram, isn't it? It's going to be up here and then along here. Okay, so that would be the probability of n/25 times n-1/24. Okay, and we know that the probability that both students are boys is 7/20, so we know the answer is 7/20. Okay, so we want to find out n basically. So what we've done here is we formed an equation in n, which we now need to go on and solve. Okay, right, so combining those two fractions together, we're multiplying, which is just numerator times numerator, so that's n-1 on the top, denominator times denominator, and 25 times 24, that comes out to be 600. So n-1/600 is 7/20. So what could we do here? So we cross multiply that 600 over, so I'm going to get n-1 is 7 times 600/20. What's that then? So 600 times 7 divided by 20, that comes out to be 210. So n lots of n-1 is equal to 210. Okay, right, so I think what we're going to do here is we're going to have to form a quadratic and solve it then. So multiplying out the bracket, I'm going to get n squared minus n, and then bringing the 210 over back over to the other side, minus 210 is equal to 0. Okay, does it factorize? It'd be handy if it did. 210, what could be factor pairs of 210? They're going to have to be quite close together. Well, they have to be like 1 apart. Can I think of two numbers 1 apart that multiply together to give me 210? Okay, well, the root of 210, root 210, that's 14. So what about 14 and 15? 14 times 15? Yeah, that's 210. So I'm going to say that I've got 14 and 15 in here then, and then n and n. It's minus 1, so the 15 needs to be the minus 1, and then the 14 is going to be positive. So I've got n plus 14, n minus 15, giving me solutions that n is minus 14 or n is 15. Now, one of those solutions makes absolutely no sense. I can't have negative 14 students or boys. That makes no sense. So it has to be that one there. Okay. Now, sometimes when you form an equation that's a quadratic and you go on and solve it, you know, whilst your answer might be a solution to the quadratic, it's not necessarily a solution to the actual problem that you're modelling with a quadratic, in this case the number of boys. So the number of boys here has to be 15. So number of boys, n equals 15. That's the only answer. Okay, job done. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.